Hello students, this is Ms. Slate and welcome back to Chemistry A. Today we're going to be talking about density. But first, let's talk about a couple of the basic properties of matter. One of the most basic properties of matter is mass. Mass simply represents the amount of matter, or atoms or molecules, in an object. The units we use for mass are grams, and we're going to be measuring it with a balance, sometimes a triple beam balance like shown below, occasionally an electronic balance. The other most basic property of matter is volume. And volume is simply the amount of space that an object takes up. The units we use for volume are going to be milliliters or cubic centimeters, depending on the application. And volume is measured with a graduated cylinder or with a pipette, never a beaker. So in class, we looked at the relationship between mass and volume, and we got some graphs similar to the one that you see on the screen. And what we determined is that mass and volume are directly proportional to one another, and that the slope of a mass versus volume graph actually represents the density, where density tells us that for every 1 milliliter of volume, there's a certain amount of mass for a substance, and density is unique to every substance. So now let's talk about how we can use density to determine the mass or volume of an object. All right, let's talk about density calculations. First off, we need to know that the basic formula for density is that the density of an object is equal to its mass divided by its volume. When we have to do any kind of story problem, what we should first do is analyze what information is given to us in the problem, as well as what the problem wants us to find. Our first example says a piece of copper has a mass of 241.9 grams and a volume of 27.0 milliliters. What is the density of the copper? Well, in this case, our given information is our mass, 241.9 grams, and our volume, 27.0 milliliters. And what they want us to find is density. Well, if we have mass and volume, we can use our density equation to figure out the answer to this question. So my density is just going to be 241.9 grams divided by 27.0 milliliters, which comes out to 8.95925 and continues on. Now, this is not our final answer because we always need to be rounding our answers to the correct number of significant figures. 241.9 has 4 sig figs in it. 27.0 has 3 sig figs. If you're doing division, you need to round to the fewest total number of significant figures, which in this case would be 3. So our final answer for density should be 8.96 grams per milliliter. We also need to make sure we always have units on all of our numbers. It will not be a fully correct answer if it does not have the correct units. So this is the simplest type of density calculation. Let's look at a couple others that require us to do a little bit more. In this question, it says lead has a density of 11.36 grams per milliliter. What is the volume of 6.53 grams of lead? Well, let's start with what information they gave us. They gave us the density, 11.36 grams per milliliter, and they gave us the mass, 65.3 grams. They want us to find the volume. And we also know we have an equation for density where density is mass divided by volume. At this point, you have two choices. You can put the numbers into the equation right now and then just rearrange things to solve for volume, or we can rearrange the equation first and then put the numbers in. I'm going to show you how to rearrange the equation first, but it doesn't really matter which way that you do it. So if we are rearranging this equation, we need to make sure that volume gets out of the denominator. To do that, we're going to start by multiplying both sides of the equation by volume. That gives us volume times density equals mass. To get volume by itself, we're just going to divide both sides of the equation by density. And so we get a new equation of volume equals mass divided by density. Now we have rearranged this equation to be solvable for volume, which is what we want to find. Now we can go about plugging in our numbers. So that means taking our mass, 65.3 grams, dividing by our density, 11.36 grams per milliliter. This gives us an answer of 5.74823 ... Again, we need to always make sure any calculation we do, we are rounding to the correct number of significant figures. 11.36 has 4 sig figs in it. 65.3 has 3 sig figs. When you're doing division or multiplication, you need to round to the fewest total number of significant figures. In this case, 3. So our final answer would be 5.75 milliliters. I know that my units are milliliters, first off, because it's a volume. Secondly, because grams divided by grams will cancel and just give me milliliters. Let's look at one more example. In this question, it tells us iron has a density of 8.7 grams per milliliter. What is the mass of 102 milliliters of iron? So they are giving us density again, 7.87 grams per milliliter. They are giving us volume, 102 milliliters. This time they want us to find mass. Again, we know density is mass divided by volume. And at this point, once again, you could just plug the numbers in and then solve, or we can first rearrange the equation to solve for mass. To get mass by itself, I just need to multiply both sides of the equation by volume. And then I get mass is equal to volume times density. Now that my equation is rearranged, I can put my numbers in. Mass equals my 102 milliliters multiplied by 7.87 grams per milliliter. This gives me an answer of 802.74. Again, though, rounding to sig figs. 7.87 has 3 significant figures. 102 also has 3 sig figs, which means my final answer needs to have 3 significant figures. So my final mass is 803 grams. And that is the basics of density calculations. If you know the formula and you can identify what you're given and rearrange that formula, you're going to be good to go for density.